Hello all, welcome to Public Cloud Design Tips and Tricks again. Today's topic is AWS Elastic Load Balancer. The problem statement is how to load balance traffic for enterprise grade solutions. Solutions are Azure Load Balancers from Microsoft Azure, Elastic Load Balancer from AWS, and Google Cloud Load Balancer from Google Cloud. Now, what is Elastic Load Balancing? Elastic Load Balancing distributes traffic across multiple targets, sits in different availability zone. The target can be an EC2 instance, containers, IP address, etc. It monitors the health of registered targets of backend systems, and it can scale based on different traffic volume. When it gets increased, it can scale out. Now, a simple example of elastic load balancing is there are three consumers sitting in the left side: client A, client B, client C. There is a load balancer in between the target systems and the consumer. Target systems sitting in three different EC2 machines, and the load balancer is playing a role of routing the request based on different demands from the consumers. So that is how it works. Now, what is ELB? ELB is a managed capability from AWS. There are four types of elastic load balancer possible. They are classic load balancer, network load balancer, gateway load balancer, especially hub and spoke centralized architecture when you need, and application load balancer. Now, what is classic load balancer? This is the oldest form of load balancing, and it is also called like previous generations LB. And this is only meant for EC2 classic instances. It does not support path-based routing, and it handles the request based on one single URL basically. So that is how it works. Now, what is network load balancer? It's a type 4 or layer 4 load balancer, and the routing decisions made by TCP layer, and it can handle million of requests per second. It can also support static IP, and it can be used to load balance TCP traffic. So that is where it is used. In the diagram, there are EC2 machines in different availability zones, and then there is a network load balancer sitting just on top of it. This is the most important load balancing is application load balancer. It's a layer 7 load balancer, and this is especially used to handle applications request basically, or the application layer you can say. And routing is based on HTTP and HTTPS in the application layer, and it supports both path based and host based routing. It also can support static IP, and it can also be used to load balance TCP traffic. So in this example, like there are different applications and they are sitting in availability zone, and there is an application load balancer which is handling requests to route the consumer request to different application based on path-based routing or could be a host-based routing. The fourth one and quite important one is a gateway load balancer. It is especially used to deploy, scale, and manage your third-party virtual appliances. So when you are trying to integrate different appliances with a central way of working, basically, then this load balancer comes into picture, and its main responsibility is to route the traffic to different appliances, external appliances, and can be useful to integrate partner solutions or marketplace. It can also scale up and scale down based on the demand, and it also works good to the endpoints basically of other services when you are centrally managed this gateway basically. Okay? And it enables a hub spoke kind of a architecture within your organization. For example, like let's say if your workloads sitting in different networks. That trying to talk to internet applications, then probably this is the best solutions where you can have a hub network where you have virtual appliances like firewalls, and then the gateway load balancers will route the request of the spoke network which the consumer is initiating uh, through the firewall basically. So That is how it is used, or it achieves the hub and spoke model basically. Now, what is the benefit of load balancing? Or load balancer is highly available. SLA is approximately 99.99%. Flexibility routing is based on IPs, so multiple applications can be deployed in a single instance. Secure in nature enables security in service and network level. It can scale up to different level based on million of requests, and it can also support hybrid scenario with on-prem and off-prem capability. Monitoring enable a robust monitoring and audit capability. So these are the benefits of load balancer or AWS load balancer. Now, if you want to deep dive more into it, you can always follow the links from AWS, and you can do little bit of hands-on also on this, and you can learn different type of load balancing and different kind of situations. So that's it for the day, and thank you. Have a good day.